eigenvalues, immediately we do the following: 1 minus lambda, 1 minus 1 minus lambda. Then, so this is the expression of A minus lambda I. And now the determinant of this expression should be equal to 0. Then we have here, 1 minus lambda times minus lambda plus 1. This is equal to 0. Okay, is this correct? 1 minus lambda plus 1, 0. Good. Then here we have that minus lambda times minus lambda. This is lambda square minus lambda plus 1. This is equal to 0. Then lambda 1, lambda 2. This would be equal to minus 1 plus minus b square minus 4ac. B square is 1 minus 4 over 2. So this is equal to this. Sorry, this minus b. That's 1, right? Can you confirm this? Is this 1 or minus 1?
1.
So this is 1. Okay. Plus minus I square root of 3 over 2. Okay, because wait a second. So this is 1 over 2 plus minus the square root of minus 3 over 2. This is 1 over 2 plus minus the square root of minus I, the square root of 3 divided by 2. So finally, we say that lambda 1, 2, it's equal to 1 over 2 plus minus square root of minus I. Sorry, this is minus 1. This is minus 1 because minus 1 times 3 is minus 3. This is I square root of 3 over 2. Meanwhile, what is lambda 1, 2? Lambda 1, 2, it's equal to the E. So we have done this before, but we can have a look. This is equal to e to the power I times the angle of 60. And lambda 2, it's equal to e to the power I minus 60. Now, this is not something essential, but now what is required from us is to find the eigenvectors. How do we find the eigenvectors? We use the same similar trick. Here, we substitute one of the eigenvalues, which is 1 minus, let's subtract the first one, minus 1 over 2, minus, because it's minus, minus I square root of 3 over 2. Then here we have 1, minus 1, and this is going to be minus lambda. Minus lambda, it's minus 1 over 2, minus I square root of 3 over 2. That's good. Now this became a little confusing, probably. So we can separate this. This is our 2 by 2 matrix. And here we multiply with AB, and this all should be equal to 0, 0. And then here we get 1 minus 1 over 2. This is 1 over 2 minus I square root of 3 over 2 minus 1, 1. And this is minus 1 over 2 minus I square root of 3 over 2. Okay, I just rewrote this one because I thought I could make this a little simplified to some degree. Again, here we need only one equation. In this case, this single equation that we are going to have. Wait a second, maybe this is better. Okay, so let's multiply the first row with this column. So here we get 1 over 2 minus I square root of 3 over 2 times A plus B. This is equal to 0. So then the only thing we have to figure out, we have to find a pair of numbers A, B that satisfy this condition. The simplest way to do this is this. Let's set A equal to 1, okay? If we set A equal to 1, what is B? B is going to be negative of this number. It's going to be minus 1 over 2 plus I times square root of 3 over 2. That's good. Done. So this is the eigenvector of the first eigenvalue. This is the eigenvector of this eigenvalue. And what else we can observe here is that, so this one, in fact, this is equal to 1. And this value, this has a negative cosine and positive sine. What part of the phase, so cosine is negative, that means that we are either here or here, okay, in these two quadrants. Sine is positive, so it looks like we are right here. So we are here, at this angle of 120, okay? So because this number, this is e to the power I 120, okay? This is this eigenvector, and by the way, it corresponds to this specific value. Now, this is one way to solve this one. We could, this is over, this problem. We can do the same actually for the other eigenvalue, which is gonna, it's good if we do it, because we can then, assuming that this is true, and most probably it is, let's substitute this other value here with a negative sign. So this is 1 minus lambda, so this sign is going to change. This becomes plus here, this becomes plus here. Then here we have 1 over 2 plus this expression, 1 minus 1, minus 1 over 2 plus this expression, this. And then if we multiply the first equation, sorry, the first row with this AB, we are going to get this expression. And what do we get here? So it looks like, wait a second, this is, yes. So in this case, we can set again AB. This can be equal to, we set A1, then B is going to be minus 1 over 2 minus I square root of 3 over 2. So now we know that the phase space apasira fazore is this one. Here we have the cosine is positive here and here. The sine is positive here and here, because this is when, because the vertical coordinate axis, it corresponds to the sine, sinusi, horizontalia, and cosinusit. So if we look here, we have, what is this number? Well, this is the cosine and the sine, they are both negative. So it looks like we are in this quadrant here. If we are in this quadrant here, we are talking about this value. So this is the angle of minus 120 degree. Okay, I'm talking just about this specific value here, and this other value, it was here. Now, this graphic representation, it means nothing. What is essential for us is just to figure out what are the eigenvectors, and this is what they really are based on the eigenvalue equation. Any question? Okay, so this is the final answer.